Hey everyone, so it's Day of Silence. So I'm not talking today, so I made a PowerPoint to go over the lesson so that way I can still teach without talking. So today we're going to talk about vectors on the coordinate plane. This is from chapter 12, and we're going to cover sections C, D, E, and F today. So first we're going to talk about vector components. So when we have a vector on the coordinate plane and we do a displacement, because a vector represents a displacement, that means that we change the x-coordinate and we change the y-coordinate. So, for example, if we start at the origin and move from the origin to the point 2, 5, that means that we move 2 units in the positive x direction and 5 units in the positive y direction. So that's my displacement. And so in order to represent this, I'm going to draw a vector from the origin to the point 2, 5. So here's my vector from the origin to 2, 5. And the way we write this is we write the vector OB, so O is the origin and B is the point 2, 5, and we write it using these large parentheses and then 2, 5. And yes, this notation is confusing because it looks like the choose notation. Sorry, sometimes we use different notations for the same thing in math. But when we write the vector like this is called component form. Now, this is really important. If we define the vector I to be the vector 1, 0, and we define the vector j to be the vector 0, 1, then basically I is representing steps in the x direction and j is representing steps in the y direction. So we can write vector OB as 2i plus 5j. And when we do this, this is called the unit vector form of the vector. So when you see I and j, you need to know that that's what they mean. So here's a really obvious statement. Two vectors are equal if and only if their components are equal. Shocker! Not really. Now we're going to talk about the magnitude of a vector. So if we're given a vector v with components v1 and v2, then its magnitude, or its length, is given by the equation magnitude of v, and we use absolute value bars to indicate magnitude, equals the square root of v1 squared plus v2 squared. So v1 is the first component and v2 is the second component. And this equation is exactly equivalent to the distance formula and the Pythagorean theorem. So basically, if I want to find the length of this vector, well, this is the hypotenuse of a right triangle. I can draw a leg here and a leg here, and those would be the two legs, and they have length 2 and length 5, and then this is the hypotenuse, and then that's where the Pythagorean theorem comes into play. So, let's find the magnitude of this vector. I kind of gave you a hint. So I'm going to pause the video, take about 30 seconds to find the magnitude. Okie dokie. So that was hopefully pretty easy. You should have gotten that by just plugging into the formula. You get the square root of 2 squared plus 5 squared, which is the square root of 4 plus 25, or square root of 29. So that was pretty easy. Now we're going to talk about unit vectors, which you've already seen. A unit vector is a vector whose magnitude is equal to 1. So therefore, both I and j are unit vectors, and you can prove that pretty easily. So here's a practice problem. Suppose that the vector 0.5, 5/10, 1/2, k is a unit vector. Find the value of k. So I'm going to pause here for a second and figure it out. Okay, first we need to write this using the formula for magnitude. And when we do that, we plug in, we get 5/10 squared plus k squared. Square root of all that is equal to 1. We need to solve this equation for k. So first we're going to simplify 5/10 squared as 2500 squared. Now to do this, solve this, we're going to square both sides. 2500 plus k squared equals 1, because 1 squared is 1. Now I'm going to subtract 2500s from both sides, and that gives me that k squared is equal to 3/4, and then by taking the square root, I get k is equal to plus or minus the square root of 3 over 2. So hopefully you were able to follow that reasoning. Alright, next we're going to talk about algebraic operations on vectors, and the good news is this works pretty much how you would expect it to work. When we add or subtract vectors, guess what? We add or subtract them component by component. So here's the example for addition. With subtraction, it's exactly the same. So if A has components A1, A2, and B has components B1, B2, when I add A and B, I add the first components together, and that's my new first component, and then I add the second components together, and that's my new second component. This also applies to negative vectors, and that's how we get to subtraction. To find the negative of a vector, you just multiply both of its components by -1, and we can see that right here that both of these components have been multiplied by -1. Basically, opposite, change the sign, all that good stuff. And next we're going to talk about scalar multiplication. So remember that scalars are numbers. We have not talked about how to quote-unquote multiply vectors by vectors yet. We're going to talk about that a little bit later, and it's a little complicated because when you multiply a vector by a vector, you don't get a vector. And that's why we don't call it multiplying. But anyway, to multiply any vector by a scalar, you multiply every component by the scalar. So if k is a scalar, just some number, then when I multiply a by the scalar, I just multiplied each component by that same number. Pretty easy. All right, so now it's time for us to do some practice problems. So let's let vector u have components -3, 4, v has components 2 and 1, and w is written as 5i minus 2j. Yes, I changed up the form there. So you need to find all of these things, and for the last one, it's asking you if k, so k is a scalar, if k times the vector u is a unit vector, what is the value of k? So we're going to take about 5 minutes to solve these problems. It's pretty easy, and then we'll go over the answers. Alright, so let's take a look at the answers. You should have gotten these answers. If you didn't, go double check your work. Hopefully I didn't make any mistakes. I do want to talk about number 6. When we took the magnitude of u, which was question 1, we got 5. And then the scalar k that we had to multiply by to get a unit vector, it turned out that we could get either plus or minus 1/5, which is the reciprocal of the magnitude of u. We will see this fact again. This is very important. All right, moving on to the next part. Now we're going to talk about vectors between 2 points on the coordinate plane. So let's suppose we have 2 points, A and B, on the coordinate plane, and A has coordinates A1, A2, and B has coordinates B1, B2. We want to find the vector from A to B. Well, we're going to see this in a picture on the next page, so if this is a little confusing right now, you know, when you see the picture, it'll be a little bit clearer. But basically, we're starting at A. So I'm going to go from A to B by going from A to the origin, and then from the origin to B. So to go from A to the origin, I need to travel along the vector negative OA. And then from the origin to B, I travel along the vector OB. So this gives me that the vector AB is equal to the sum of the negative of vector OA and the vector OB. And just rearranging terms, this gives me OB minus OA. But wait a minute, we know what the components of OB and OA are, because going from the origin to B, that's the components of that vector are just the coordinates of B. So I can write vector OB as B1, B2, and vector OA as A1, A2, and therefore vector AB is just B1 minus A1, B2 minus A2. Pretty easy. Let's look at this diagram. This makes it clear. So here's my point A, here's my point B. So to get from A to B, I'm going along the negative vector OA, and then I'm traveling along vector OB. So that lets me start at A and end at B. So that explains the rule. So here's some more practice problems. Again, we're going to take about 5 to 7 minutes to do these problems. Again, they're pretty easy. So I'm going to pause the video here, take 5 to 7 minutes, get these problems done. All right, let's take a look at the answers. First 3 were pretty easy. Those are the vectors. For number 4, you should have gotten the vector written this way, and then when you simplify the magnitude, you do all that out. That gives you this quadratic. If you didn't simplify it, then you definitely had to simplify it down here for problem 5. And then this is just doing some algebra steps to solve, and you get k equals 0 or k equals 6. And it makes sense that there should be 2 solutions, because basically if I find, you know, one point that's 5 units away, then I can just reflect that, because the x component or coefficient is, or yes, the core coordinate is going to stay the same. If I just reflect it over that line, I get the other one. So that's why there's 2 solutions. All right. So hopefully, if all went according to plan, we finished a little early, so that's going to give you time to start work on the homework. I apologize. Your homework is going to be to read pages 296 through 304. This is sections G and H. These are pretty easy sections. Basically, everything we just did today with 2 dimensions, these sections extended to 3 dimensions. Pretty easy. And these are the problems that you need to do. Yes, there are a lot of them. I'm sorry. So to compensate for that, I really don't want you to spend more than 1 focused hour on this assignment. Take about 20 minutes to do the reading and then 40 minutes to do the problems. Again, most of these problems are pretty easy. Well, here comes the really sad bad news. There's a spring break assignment. This assignment is going to be collected for a grade, so you need to write up all your solutions fully and neatly. Before you leave today, please make sure that you have a formula booklet. I have some that I can give you. You can use the formula book. You definitely should use the formula book. You can also look in the textbook for help. These are designated non-calculator questions, so you should not be using a calculator. And some of the questions have multiple parts. You need to do all parts of every question. This assignment is designed, I only assigned 10 questions. There are some pretty easy questions. There are some harder questions. So if you get done in 90 minutes, that's awesome. My expectation is that it will probably take around 2 hours. If you find yourself at the 2-hour mark and you're going, oh, I've only done about half the questions, take a look at the other questions. Spend your last half hour on the questions that you know how to do. I want you to kind of treat this like a practice IB test. There's a mix. There's some short questions and there's some longer questions, and it's a mixed bag. These are all review questions from the back of the book. It's your spring break. I don't want you to overwork yourself. Please don't spend more than 2.5 hours on this assignment. That would just make me sad. And if it makes you feel any better, I have to spend my spring break writing up solutions to them. So, I kind of, it's not fun for me either. I believe for most of the questions there are answers in the back, but there's not full solutions. So you can use the answers in the back to double check yourself, but it's not going to be full solutions. So make sure you have full solutions written up for these. So these are the 10 questions. I'm not going to read them. You know how to read. Please copy them down and do them. I will, depending on how many people are in class tomorrow, I can either give you time in class tomorrow to do it. If I have most of the class, then I will go on to talk about the next topic, because I do want to make sure we get vectors done. And this is going to be good review for the IB test. So hopefully this all worked pretty well, and I will see some of you tomorrow. If I don't see you, have a fantastic spring break, and please, find some time to enjoy yourself. Please do not spend the whole time working, but do set aside some time to do this assignment and to study everything you need to prepare for the IB exam, because I am very confident that everyone is going to pass, but that's not going to happen if you don't study. So if you have any questions, please feel free to email me. You all should have my email address. And I will see you all either tomorrow or when we get back from break on Tuesday. Have a great day.